Semiconductors are the unsung heroes of our digital age. These tiny, intricate pieces of technology are the backbone of modern electronics, silently working behind the scenes to make our digital lives possible. These tiny chips power everything from smartphones and laptops, enabling us to stay connected, work efficiently, and entertain ourselves with just a few taps and clicks. They are also integral to the functioning of modern cars, making them safer and smarter, and to artificial intelligence systems, which are becoming increasingly prevalent in our daily lives. The industry that produces these semiconductors is a global powerhouse, driving innovation and shaping the future of technology. It is a complex and highly competitive field where precision and cutting-edge research are paramount. At the forefront of this industry stand giants like Taiwan Semiconductor Manufacturing Company, or TSMC, and Intel. These companies are pioneers in semiconductor manufacturing and design, constantly pushing the boundaries of what is possible. Their state-of-the-art facilities and relentless pursuit of innovation have set the standard for the industry, making them leaders in the global market. However, a new player is rapidly emerging on the global stage: China. With its vast resources and strategic vision, China is positioning itself as a formidable competitor in the semiconductor industry. China's ambition to become a self-sufficient technology powerhouse has put its semiconductor industry on a fast track. The country is investing heavily in research and development, building advanced facilities, and nurturing a skilled workforce. The country is investing heavily in research and development, aiming to climb the value chain and challenge the dominance of established players. This includes not only manufacturing, but also the design and innovation of new semiconductor technologies. China's goal is to create a robust and independent semiconductor industry that can compete on the global stage. This ambition is fueled by the strategic importance of semiconductors in a world increasingly driven by data and computing power. As our world becomes more interconnected and reliant on digital technologies, the role of semiconductors will only grow. They are the heart of our digital world, powering the innovations that shape our future. China's journey in the semiconductor industry is marked by rapid growth and a relentless pursuit of technological advancement. Recognizing the strategic importance of semiconductors, China has made significant strides in developing its domestic chip-making capabilities. While still lagging behind global leaders in certain areas, China is quickly catching up, driven by government support, substantial investments, and a burgeoning domestic market. This rise is particularly evident in the chip equipment sector, a critical part of the semiconductor supply chain. Companies like Nora and SME are making their presence felt, challenging established players with their increasingly sophisticated offerings. This progress, however, is not without its hurdles. China still faces significant challenges in key areas, particularly in the development of advanced lithography machines. At the forefront of China's semiconductor equipment push are companies like Nora Technology Group and Semiconductor Manufacturing International Corporation, or SME. These companies have emerged as national champions, spearheading the development and production of critical equipment needed for chip manufacturing. Nora, for instance, has made notable progress in etching, deposition, and cleaning equipment, essential processes in chip fabrication. SME, on the other hand, focuses on lithography machines, a particularly challenging area for China. While still behind the industry leader ASML, SME's advancements represent a significant step towards greater self-sufficiency in chip production. The progress of Nora and SME underscores China's commitment to building a robust and independent semiconductor industry. Lithography is the linchpin of semiconductor manufacturing, and it is here that China faces its steepest challenge. The precision and complexity involved in this process are immense, requiring state-of-the-art technology and expertise. Lithography machines, particularly those using extreme ultraviolet or EUV technology, are incredibly complex and expensive to develop. These machines are essential for producing the smallest and most efficient semiconductor chips, which power everything from smartphones to advanced computing systems. ASML, a Dutch company, holds a virtual monopoly in this field, supplying its cutting-edge machines to chipmakers worldwide. Their technology is unmatched, making them the go-to supplier for the most advanced semiconductor manufacturing needs. China, however, is largely cut off from acquiring ASML's most advanced EUV machines due to export restrictions. These restrictions are part of broader geopolitical tensions and trade policies that limit China's access to critical technologies. This lithography gap poses a significant obstacle to China's semiconductor ambitions. The inability to procure the latest EUV machines means that Chinese manufacturers are at a disadvantage, relying on older, less efficient technology. Without access to the most advanced lithography equipment, Chinese chipmakers face limitations in producing the most cutting-edge chips. This impacts their competitiveness in the global market, where the demand for high-performance chips is ever increasing. Overcoming this challenge is a top priority for China, which is investing heavily in research and development to close the gap with ASML. The country is pouring resources into developing its own advanced lithography technology, aiming to become self-sufficient and reduce its reliance on foreign suppliers. This ambitious endeavor reflects China's broader strategy to become a leader in high-tech industries and secure its position in the global semiconductor market. Section 5. TSMC, the foundry giant and its innovative edge. Taiwan's Semiconductor Manufacturing Company, or TSMC, stands as a titan in the semiconductor industry. Unlike companies such as Intel, which both design and manufacture their chips, TSMC focuses solely on manufacturing. This pure-play foundry model has propelled TSMC to the top, making it the go-to manufacturer for companies like Apple, Qualcomm, and Nvidia. TSMC's success is built on its relentless pursuit of technological advancement. The company consistently pushes the boundaries of miniaturization, producing chips with transistors so small that they are measured in nanometers. This technological prowess has allowed TSMC to maintain its leading position, supplying the chips that power our most advanced devices. Section 6. Intel, a legacy of computing power facing new challenges. Intel, a longtime leader in the semiconductor industry, is synonymous with computing power. From its iconic Pentium processors to its latest Xeon chips, Intel's products have shaped the evolution of personal computers and data centers. However, in recent years, Intel has faced challenges in maintaining its once dominant position. The rise of mobile devices and the increasing demand for energy-efficient chips have put pressure on Intel's traditional strengths. Moreover, the company has faced manufacturing delays, allowing competitors like TSMC to gain ground. In response, Intel is undergoing a strategic shift, investing heavily in new manufacturing technologies and expanding its foundry business to compete more directly with TSMC. Section 7. Geopolitical cross-currents, navigating trade tensions and technological independence. The semiconductor industry operates within a complex geopolitical landscape. Trade tensions, particularly between the United States and China, have cast a shadow over the industry. The U.S. government has imposed restrictions on the sale of advanced chip-making equipment to China, aiming to curb its technological rise. These restrictions have had a significant impact on Chinese companies, limiting their access to crucial technologies. However, they have also fueled China's determination to achieve greater self-sufficiency in semiconductor production. The push for technological independence is now a top priority for China, as it seeks to secure its own supply chains and reduce its reliance on foreign companies. Section 8. Impact and competition, how China's rise affects the semiconductor landscape. China's emergence as a major player in the semiconductor industry is reshaping the global landscape. Over the past decade, China has invested billions of dollars into its semiconductor sector, aiming to reduce its dependency on foreign technology and become self-sufficient. This rapid growth is not just about meeting domestic demand, but also about positioning itself as a global leader in semiconductor manufacturing. The country's growing demand for chips, coupled with its ambitions for technological independence, is creating both challenges and opportunities for established players. Companies around the world are now re-evaluating their strategies to either collaborate with or compete against Chinese firms. This dynamic is leading to a more complex and competitive global market. TSMC, for instance, is navigating a delicate balance, supplying chips to Chinese companies while also facing increasing competition from them. The Taiwanese giant is known for its cutting-edge technology and has been a key supplier to many Chinese tech firms. However, as Chinese companies ramp up their own production capabilities, TSMC must innovate continuously to maintain its leadership position. Intel, facing its own set of challenges, is also feeling the heat from China's rise. The American semiconductor giant has been a dominant force in the industry for decades, but the rapid advancements in Chinese technology are pushing Intel to rethink its strategies. The company is investing heavily in regaining its manufacturing edge and expanding its global footprint to stay ahead in this increasingly competitive market. Intel's efforts include building new fabs, enhancing its R&D capabilities, and forming strategic partnerships to bolster its position. The semiconductor industry is entering a new era, marked by intensifying competition and a shift towards a more multipolar landscape. As China continues to rise, the global semiconductor market is becoming more fragmented, with multiple centers of innovation and production emerging. This transformation is likely to drive further advancements in technology and reshape the future of the industry. Section 9. The Future of Chips, a Multipolar Semiconductor World. The semiconductor industry stands at a crossroads. China's relentless pursuit of technological advancement is reshaping the global landscape, challenging the dominance of established players like TSMC and Intel. The coming years will likely witness a more multipolar semiconductor world where China plays an increasingly prominent role. This shift will have profound implications for the global economy, technological innovation, and geopolitics. The competition in the semiconductor industry is ultimately a competition for technological leadership and the power that comes with it. As China continues its ascent, the world will be watching closely to see how this competition unfolds and what it means for the future of our digital world.